Hello everyone, so in this video, let us talk about one more easy little problem from LeetCode. The problem is check if every row and column contains all the numbers. Pretty much simple. As the problem statement goes like this, you are given an n cross n matrix as you can see in the input. Now, a n cross n matrix is called valid if every row and every column contains all the integers from 1 till n inclusive. Okay, so let's say all the columns and all the rows contain all the numbers from 1 till n. So it is a 3 cross 3 matrix. So 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3, as you can see, some sort of a Sudoku. Not exactly Sudoku, but like some sort of Sudoku that all the you can say 3 by 3 like rows, all the 3 rows and all the 3 columns should be containing all the numbers from 1 to n inclusive. You just have to check that whether it is verified or that is actually present inside the matrix or not. That's it, nothing much complicated. So multiple approaches you can do, like a column wise traversal and then a row wise traversal over this matrix, and just check out that whether all the numbers are present or not. You can just insert all these numbers inside some set, you can say, and if all the numbers are present, no repetition is there inside the set, which means that all the numbers are occurring only once, and they are from 1 till n. Pretty much simple. You can just do that. You can also do this. So if you do a row wise and column wise, it will be like 2 time traversal over this matrix. You can have done this in 1 time traversal as well, because it is an n cross n matrix. You can just do a for loop, nested for loop. So in one row wise traversal and one column wise traversal as well, you can do in a single loop as well, and then you can just push all of them inside the set, and then just check out that whether this set is only consisting of these numbers only once. If it is occurring more than once, then that is false. So pretty much simple, nothing much complicated as well. Let's move on to the code part now. What we have done is that we have created 2 sets, and we will just iterate over this complete matrix in a nested for loop. So this is from 0 till n, this is 0 till n. So this is for checking out for every row. So this is a row wise traversal, like because I'm doing ij. Okay, so for every, let's say, ith number, like this, okay, ij, so we are taking about ij, that is doing a row wise traversal here. So row wise traversal means that the complete number should not be occurring twice in a row, and again doing a column wise traversal here as well in the same, because it's the like you can say the dimensions are same, so you can directly just do a column wise traversal in the same loop as well, because the logic is same. Okay, if I do a column wise traversal, I will just do the same for loop, but this is the column wise traversal logic, this is the row wise traversal logic, so I can just put them in the same for loop because the loop will be the same. So I can just do the same thing and just check out of all of them. It is perfectly fine. If it is fine, I have checked it for the first row and first column, and that's just clear this complete set and just do the second row and second column and so on. In the end, if nothing breaks and nothing hits this false condition, then answer is true. Else if the answer is false. Okay, this is just a nested for loop. So that is O of n square, and then for every n square we are doing some set insertion and checking out. So it is again O of log n. So you can say that the overall tangosity is n square log n. That's it. So that's the complete logic and the code part for this particular problem. If you still have any doubts, you can mention in the comment box for this particular video. I will see you in the next one. Till coding, and bye.